Okay, we're going to continue on with mechanisms and the mechanism question. We spoke about the worm gear already, and we're going to do a calculation today. Okay, so this is from the exam papers, and we'll just have a look at the questions first here on the right hand side. The sketch shows a mechanism to lock and unlock a door. Okay, so we can see a motor, see the mechanism that's in there, we can see the teeth and the bolt that moves left and right to lock the door. Okay, so question number one says name the mechanism shown at X and state one advantage of using this mechanism in a lock. The name of it, okay, so over here on the left hand side I've written the name of the mechanism at X is a worm gear. Okay, the advantage of it is you have no slipping with that gear, it can act as a lock, it will slow down the speed, it is compact, it will fit into small spaces, things like that. Okay, so any one of those is an acceptable advantage of using that mechanism. Question 2. The mechanism at X changes the direction of motion through 90 degrees. Okay. Name and sketch another mechanism which also achieves this change. The one I've gone for is the bevel gear. Right, they're bevel there at 45 degrees. You can see them here. The bevel gear has kind of a camber on the side of the gear, and it is changing through 90 degrees. So the two 45-degree bevels together make 90 degrees. So this shaft out here goes to your motor, that's your input, and then this one goes to your output. So you can clearly see here the 90 degrees. Okay. Number 3. Now this is the one I suppose I'm really want to emphasize today, the calculation. So using the information given in the sketch, calculate the length of time for which the motor must run to move the bolt a distance of 30 millimeters. Okay, so how long does this motor have to be spinning in order for this to move 30 mil? Okay, so we have some information given to us. Firstly, the motor, I'm going to write my information over here. The motor is spinning at 150 RPM, and secondly 5 teeth equals 10 millimeters. Okay, so that's the information we've been given. It also tells you that there's 20 teeth on this wheel here, but for this question that's not really necessary. Okay, but some information, right, that is that you already know, but it's not written on the page, is that we already know that every time this worm spins around once, so every revolution of this worm will move this one tooth. Okay, so when this spins around, this tooth, this one here, moves from here to there. Okay, so we need to figure out how many times does it need to move, okay, and how long does it need to do that for. So if 5 teeth move 10 mil and we want 30 mil, and how many teeth is 30 mil? Well, there's 3 times the amount of distance, so there must be 3 times the amount of teeth, so that would be 15 teeth. Okay, so at least we now know we need to move 15 teeth in order to get 30 millimeters of distance. Now I've written a formula up here, right, and it's a very, very simple formula. Required revolutions over total revolutions multiplied by the time, and I should have written down there in seconds. Okay, so required revolutions over total revolutions. We need to move 15 teeth, so we need to move this fella 15 times. Now I already told you there a second ago that every time this spins around once, this moves once. So if we want this to move 15 times, how many revolutions do we need? We need 15. So go back to our formula. Required revolutions over total revolutions would be, required would be 15 because that's how many we need. So we need this to move 50, or this to spin around 15 times, over total revolutions, which is our speed, 150 multiplied by the time in seconds. So in a minute we have 60 seconds. So we put that 60 over 1. Now this basically becomes a very simple maths problem. So what we have here is 15 divide, or you can divide 15 into 150. So that goes to 1. That goes to 10. So that's a tenth. Now we're multiplying 60 by a tenth. So that's 60 over 10. And cross off the zeros is 6. Now it's not just 6. What is it? 6 seconds. Okay? So the required time for the motor to be spinning to move 30 millimeters is 6 seconds.